Hej och välkomna till vårt seminarium med Predictive Movement, a competitive neutral collaboration site for transporting people and goods with the help of AI. And I'm sorry I started off in Swedish, so welcome those of you who only speak English as well. I am Johanna Lindberg and I work at Luleå University of Technology, and I've had the pleasure of being the project leader as this platform has been developed. Let's start off warming up a bit. I also want to introduce, this is a bit of a slow start. I also want to introduce Christian Landgren, who will be talking later. He's one of the initiative takers of this platform, and he's been the main architect for developing it. And I also want to highlight Anders Gullberg, an associate professor at the Royal University of Technology, Emerita, and he's also been one of the initiative takers. So let's start off and warm up a bit with a short film. So now you're a bit warmed up and you know a bit about predictive movement. So I will actually start with digging deep down into my research subject, information systems, and presenting where we find where predictive movement is. I think it's, imagine yourself in the pre-digital era. We didn't have any digital services to help us around. And of course, we had collaboration at the time, and people were traveling together and using transports and sharing it. And people gave each other the information they needed. And then we got into the digital era and something happened. We developed different the digital services, but it was only within our own organizations, because that was what we were able to do. The data that was shared was then within the organizational boundaries, and the system provided information that people requested. The big tech companies like Amazon and Google and Spotify, and you know them all, they changed it. They decentralized the usage, but the ownership was then still centralized. And the tech companies, they created a good collaboration for us, but we shared then the data with the tech companies. The new thing they also did was the system provided information that people actually needed. Where we want to take predictive movement is one step further. We want to also not just
decentralize information or the usage, but also the ownership by being an NGO. And then also we're sharing the data within an open source platform, and we've made this platform the way that we only share the data that is needed to be shared. So we don't give it away, the data, to anyone, we keep it ourselves. And the system, as within the tech platforms, is then the information that we shared is, of course, something that we need. And then I once again want to stress that predictive movement is a competitive, neutral, non-commercial
collaboration side. Really, what we want to do is that we want to introduce a new level into the transport industry. You may compare this with the business model for broadband expansion, where we also have different actors for the physical and the digital infrastructure. But the digital infrastructure is divided into two different actors, one transmitting the data and the other one delivering services. And we believe that predictive movement will be the non-commercial actor that will be able to deliver or transmit data within the transport system. And I would say, lucky for you, we want to do this non-commercial for the purpose for all the commercial actors to increase competitiveness. I've tried, and we're working on this word. I think it's difficult in English, but you understand me. By the competitiveness, by sharing data with each other. This, whether you are transporting goods or people, whether you're active in rural or urban areas. This platform has been developed in rural areas because the future need of transport is large and it will increase. But also because the lack of commercial incentives, the actors we've been working with have been extremely innovative. But also because of the actors are less, or the fewer actors in rural areas, it has been less complex. Of course, the platform is developed with new technology as it is just developed. So we've been using AI, blockchain, route optimization, but we've also developed a digital twin as a test bed. This is an open system, so everything is open source. Developing predictive movement, we have had problems with the sharing of data. We hope the sharing of data will increase with the digital twin, so we can test before we do it in reality. But also our collaboration with Closer and their new logistics data lab for mobility. The current business models has to change to create new business model that is built on collaboration. There's a lot of things that has to change, from the tiny things that transporters get paid by stop, that per se decreases the service for the customers because of the reduce of delivery points. But the huge aspect also reducing climate emissions. If we don't collaborate, there will be more trucks on our roads emitting CO2. Predictive movement can be the key to circular business models in the transport industry. With predictive movement, we can expand the circles without our own organizations. We are talking about using digital service on the road here. So of course we need fast, stable, mobile broadband in rural areas as well. So what I'm actually saying is that we need a system thinking within the public sector to find new solutions. So I would now present you to Christian, and he will continue talking to us about predictive movement.
Hi, everyone. Thank you so much for this lovely introduction. And I'm going to help you guys to understand what we have built. But first of all, a little bit about me. I'm running a company called iTeam, and we work with digital innovation. And this is an initiative that we have made ourselves and also invested in heavily the last years, because we believe that everyone needs to contribute to helping the world solve these complex issues, and we believe that we have the tools to do it. But to talk about a little bit about how this started and also how it works, it all started with a quite naive idea that we have, on one hand, we have the cars and other vehicles already on the roads, and we know that these cars are not utilized enough. They are quite empty all the time, especially when they're returning back. And on the other hand, we have people and goods, and the needs for goods to be transported from A to B, and also the same for people, is on the other side. So if we have this problem right now, and we look at how this is done right now, we have in this picture you can see that every car takes up one person, and every you could say every truck takes up one package. And the naive idea is, of course, to see how can we find the patterns in these behaviors, and using the data and the algorithms to find this data and predict the movements that both people have, the goods have, also the transports are already on our roads. So the basic idea is to make incentives for the different actors in this industry to find ways to share the data about both where the transports are, and also what goods they have, and where the goods are headed, and also people. And combining those together and building a new platform to predict these patterns, and also sharing the data between them, will help us to reduce the environmental impacts, but also to increase the service in rural areas, and also make use of our existing infrastructure much better. And for every car that is not running on our roads, that also have another lot of other positive impacts on the environment. And also when we're looking at this from a systems perspective, we can see that we have quite many both first-hand effects on this, but also second-hand and third-hand effects that will increase the overall competitiveness of whole society. Which means that we can learn from the data we produce, but also learn from the effects of the data further on. When we look at this problem, we directly see that there have been a lot of other attempts to try to solve this since before, and the mobility as a service is definitely not something new. But as Johanna said, we have quite a few innovations in our back our sleeve that we believe are the key aspects of solving this problem once and for all. And to just summarize a little bit about what we have already built, we can say that we are, as a sharing platform, pretty similar to how Google and Facebook and Amazon are working today. They have, in their case, they have vendors on one side and buyers on the other side. In our case, we have different organizations and that have transport needs on one side, and we have the physical infrastructure on the other side. And we try to gather all this data together in a secure way, so we can combine these different data sources together. And to do that, we have developed both this database and the blockchain technology for sending data securely between these different actors. And by utilizing encryption models, we have been able to transfer data from one vendor to another one without having any leakage of data between every other actor in the system, even though everything is open sourced. Which is a very good idea when we are trying to do this. We have also developed some apps, very basic apps, to help the drivers in the trucks to know which route to take, which package to pick up, and handle all these different data points between different systems with different IDs and packaging and other integrations through our APIs. So we have they've also developed an API that people can use to access our system, but we also use a lot of other APIs in order for us to make this work. And all of those APIs and all the data sources we have been using are open data, which means that we are not using any American or others data sources to solve this problem, but we're only using public data coming from ourselves, which means that this is also data sovereignty issue. So we're not building something on top of any other systems, but we actually have control over the whole infrastructure that we have built ourselves. But this, of course, sounds like a lot of very technical terms and hard to understand. So in order for us to show a little bit more, we have developed a digital twin. And the digital twin is a system where we can simulate how these different effects, these first level effects, the second level effects, and also third level effects can look like if they're implemented today. And that also decreases the risk for all the different players that have access to data and to be able for them to share this data with each other in a sandbox environment, if we would say. So they can feel less worried about if the package arrives and do these experiments in production environment with real packages. So in order for you to understand this a bit more, we have, I'm going to show you the demo. So let's see how this works. So what you see right now is the map of Sweden, and we can see that on different points on this map, we have green dots that represents packages delivered. We have yellow dots and red dots and pink ones, and these all represent cars on the road. And if we start the simulation, we can now see that these roads are currently going on the road network and moving about to their destination. We can also increase the speed a bit, so we can see that these are headed towards. In this case, we have two cars going from Östersund, and they are both moving up to Storuman. We also have a lot of cars here in Arjeplog and other cars in Arvidsjaur. And when looking at this, you can start seeing that these cars are now moving on the road network and are heading towards new locations. You can look at this car, for example. It has 99 packages loaded, but it has a capacity of 540 packages. So that means that it has only 50% of utilization, or 20% of its utilization. We can also see these green cars moving here, and that is supposed to represent private persons picking up their packages. Because as you all know, when you expect a delivery, most of the time you're not getting the delivery to your doorstep, but rather you have to pick your package up yourself. And when all of these data is combined, we can see here on the left-hand side, we can see a counter that will already increase for every delivery that these packages have delivered, which increases all the time during this simulation. And we can now see for one day, we are right now in this municipality, we have already consumed 334 kilograms of CO2 emission just by delivering these packages in this municipality. So that means that we have a system where we can have on one side the packages, and on the other side we have the transport, and then we can, inside of this sandbox environment, we can elaborate on these different mechanisms and data sharing. And also, if we add this other layer, we can start seeing this problem that we are trying to solve. And as we see here, we have now added layers or lines between the actual car and its destinations. So, for example, we have here the blue car that is now currently delivering packages within the city. But it's after that it's supposed to go up here in the north to deliver one package here and one package here and there, and all the way up here you have different packages that are going to be delivered. But as we also see, we have a red line here stating we also are going to the same place with the red car. And if we look at the red car, we will see that this is only 5 packages that is supposed to be delivered to these different places. So what we try to do is to convince the red player here that if they just unpack their goods within the city here, and then let the blue player take those 5 packages and deliver them as well, since we know that the blue car now has all of the other places that it's also supposed to go to. And as we know, and as we see, these delivery points are always going to be, for every day, it's going to be different. So we don't know in beforehand how this is going to work and how each day is going to turn out. So this is a dynamic system where we have to all the time make sure that we optimize based on the information we have, and get as much information as possible about the future, which means that we are really dependent on getting these data points as soon as possible, and also getting these data to be shared, and also the packages to be shared in time, so we can utilize these transport that are already planned. But if we then continue with this day, we can see that these cars are going to go about their way, and as we know, the blue car is going to be having a lot of work to be able to deliver all their goods. And what we see when we take all of these data points and simulate this is that at least 30% of the CO2 emissions can be reduced if we run the same simulation again, but instead letting these optimization algorithms do its work before going out on these long trips on the outmost rural areas in these municipalities. And another interesting aspect of having this sandbox or digital twin is that we can also introduce other types of vehicles. We can introduce other types of vehicles. So, for example, if we want to simulate what will happen if we introduce electrical trucks in this system, we know that they can't run for as long as they need without charging. And if all of these cars are going to charge in the same network, we're going to have bottlenecks on different places, which means that we can introduce and simulate these type of introductions of new technologies within the system. We can see where these bottlenecks will end up being, and also include that in our algorithms that will take care of all the different aspects of optimization, including electrification. Another interesting aspect of this is that we can also introduce other types of vehicle altogether. And by restarting the simulation, I'm going to show you how we have done a simulation of drone deliveries in Västervik municipality. So now we're going to see a new color that is teal blue. That will represent 100 drones that have been introduced in our virtual experiment here in Västervik. And these drones are going to be delivering the same amount of packages that previously only trucks would deliver. And now we need to actually turn down the speed a little bit, because otherwise you're not going to see it. Because as it turns out, these drones are right now, they're modeled from one of the vendors that have these drones available today. So each drone have a capacity of only one package, but the package could be up to 5 kilos. And they can have a range of up to 3.5 or 35 kilometers in range, and then 35 kilometers back to the central points. And that means that in this municipality, we can see how many of those packages that ordinary would be for an ordinary day would be delivered by trucks. And as we saw previously, how the CO2 emission would be increasing, but also how long it took for the trucks to go to each of these places. And if you look at on the left-hand corner here, you can see the CO2 emissions now have only increased up to 7 kilograms of CO2 emissions, because these drones are very efficient. They only take one package at a time, and they all run on electricity. So, which means that it's almost no electricity at all for each of these drones. What we also can see is that it's very efficient from delivery time, because you don't have to wait for one car to be filled before you can go. You can, as soon as you have one drone that is fully charged and a package that will be delivered by it, we can just let it fly away directly. And so we can now see that now these drones have delivered their goods, and we can see that they are now turning back for recharge at central Västervik. And now we have already delivered at 7:45 in the morning for this simulated day. We have already delivered 46 packages compared to how it will look if we go and see how it's running for the other municipalities north of Sweden. Whoops. And here we haven't even started delivering the packages yet. So it's a lot of difference, and this is the idea of using this digital twin, that you can simulate different aspects of this system by having smart agents that will act as drivers in the car or act as a package being delivered. So with that said, I'm returning back to the presentation.
Okay, thank you, Christian. This is very interesting. So, as you understand, we have developed this digital twin, but we did that when we had realized that we needed to, because we started off doing pilot studies in our collaborative municipality. So we started with developing this platform in Ljusdal, and then we continued in Pajala. And there we also did actually the sharing of packages, and we realized that this is difficult. And also a colleague of mine was looking into the business models, and we needed this digital twin then to be able to actually get anywhere with this. With predictive movement. So we will don't forget that the platform is actually there to use. It's not just that we have the digital platform, the digital twin. So we did 2 more tests with only then the digital twin together with Arjeplog and Västervik. And we've been working then. Whole lot of people has been working. So the 4 municipalities has been working with us, but also the county administration in Norrbotten and the county council of Norrbotten, and then a bunch of companies. So iTeam, of course, but also Urban City, a small company where Anders Goodberg works, and a beautiful Soup, who's doing all the communication with us, and Argumento is also, and Sveriges Paketombud, and a branch organization. It's been really nice working with all these people, and it's been working really, really well, even though we only did this project during Corona. Must remember that. But I've been talking about quite a lot that we want to be an NGO. And to be an NGO in Sweden, that means that you have to work with the national objectives. And what we want to work with, or we need to work with, is the transport policy objectives. So then we're talking about that, the generational objective, and that what we're aiming on there is that we are actually this works in the entire country. So throughout the country, this platform will work. And then the accessibility. Christian mentioned that we are with collaboration, we will get more accessibility all over the country. Either we can change into new transport modes, or with the collaboration, we can get there faster, because we don't either we reduce the traffic in the cities, or we don't have to wait to fill up the trucks to be able to get cost efficient in rural areas. And then also the consideration goal, and there we are obviously looking into the environmental generational goal, and the one that we, if you go further down into the goal system, we look into the climate change goal and reducing climate impact. And I think this goal is much more interesting and much easier to work with or towards than the global goal of climate change. It's because they're saying that we should reduce the climate gas emissions. And of course we do that by reducing the amount of cars on the road. But also they say we shouldn't do any climate action without considering other sustainable goals like the biodiversity, or in our case also we cannot just stop transporting things in the rural areas. We need to we need the service all over the country. People live everywhere. We have we've heard this morning, if you were listening, we've got lots of industry here in the rural areas. We've got all the natural resources. We need transports in rural areas, but of course we need transports in the urban areas as well. So this means that we couldn't just stop the transporting, the transports. They have to be there. We have to increase services, but also looking into biodiversity. With less cars on the roads, you don't have to build new roads. New roads, they will stop the animals, the ecosystem and the animals' way they move, and also the roadkills. Less cars, less roadkills. And with predictive movement, and if it's used on a full scale, we can see that we will have less trucks on the road. And this is important because I believe that the only way we can reduce the pressure on the environment is actually to reduce the use of the environment, using less energy, using less transport, using less of everything. That is the solution, and predictive movement can be a key player in this way of thinking. So, Christian, will you please help me to summarize this? And after Christian has summarized this, our talk, we're happy to get answer some questions from you.
Yeah. So so please right now just enter whatever is in your mind in the chat, and we will have those questions read out here in the session. So please do that while I'm trying to summarize what you have learned. So in essence, what we have and why predictive movement is something you should all consider is that with predictive movement and optimization of transport services, we will increase the conditions in rural areas and the service levels. It will help the current actors within the transport system to get better efficiency from loading and carpooling. When using this not only for packet deliveries but also to travel and commute. And also you have to understand that the traffic movements within the system, when, as we could see in the digital twin, when every actor just optimizes for themselves, leads to a lot of cars running after each other on the same roads, going to the same places with just half empty cars. So with predictive movement, we can optimize the traffic movements for everyone instead of being sub-optimized for the individual company. And also, predictive movement is open source. It uses both exports and API that everyone will be able to use, but it also uses the open APIs and the open data that already is existing out there. So this is a very good way to make use of all the public funded data that is already out there. And also it prevents data collection with the intention of creating a monopoly, because right now, as we see in almost every industry, it always leads to the same thing, that one very global player takes on these complex challenges from one part of the world and then expands over to the rest. And this is a problem that probably will lead to the same type of monolithic idea. And by doing this collaborative effort in Sweden with predictive movement and open source technology, we will be able to prevent that. So instead of just doing nothing and eventually having a global player coming in and trying to solve this problem for us, we can take care of this problem ourselves. So this is a very good way to prevent that. And of course, in the end, which is very, very important for everyone and should be important for everyone, is how to, as Johanna said, make use of technology to reduce the environmental impact, but also at the same time solving and taking care of a lot of the other also goals that we have. Because just stopping transporting and ourselves and the things that we need is not the way to go. So with that said, we are opening up for questions. And Theo, do you have any questions from the chat for us?
We do. Good afternoon, Johanna and Christian. We do have a few questions for you. Where do you intend to publish the open source code?
The source code is already published. So if you go to GitHub, you can search for predictive movement, and you have all the source code available there, including this visualization, the digital twin that I showed you.
Thank you. How do you propose predictive movement to different logistics providers?
Could you
Is
repeat
it only
that?
meant to be used as a... Yeah.
Okay. No, one aspect of this is what we're doing in the future, hopefully. We are now working with Mälarhamnar. That would probably get an English name, but I hope you can translate it. It's the harbors of Mälaren. And they're working with trying to get people to transport on the sea instead of lorries. So that's a way of what we're trying to look into predictive movement, to try to get away from trucks and get companies to transport on the seas as well. And that's what we want to do with Mälarhamnar in a coming project. That's an example. Right. And of course, the drones is one example that Christian also showed us.
And self-driving cars is one other example, and other types of transport, like small delivery drones on the roads. And we will see a lot of new innovation coming, and if all of those innovation needs to also sell their services within all of this complex data network, that's going to take some time. But with this type of innovation, they have somewhere to jack their API in. They can just publish their available transports into predictive movement, and suddenly they're going to have new bookings coming into their system. So this is a very good way to also introduce new technology into the market.
And I also want to welcome you if you have any ideas on where you want to use predictive movement. Please keep in touch or call us or send us an email, because we're actually in the go to form a continuation of this project.
Yeah.
Great.
And that's also something that might be good to mention, that we are right now in something called from Vinnova, the Utmaningsdriven Innovation, UDI, and that has 3 different distinct parts. So now we have just finished the second part of that innovation program, and we are in August we are gonna start the next chapter of this, and which is much more scale. So if you sit on something, an innovation or a problem that you feel would be suitable to experiment with together with us, we are very open to collaborate with you. So please contact us if you are interested to be part of this. And also one thing that is good to mention is that the name Predictive Movement is a little bit of playing with words, because of course it happens. It's about transport. But the movement part is also in terms of a movement of organization. So we want to make this as a movement where everyone can collaborate and also collaborate on building this together with us or together with yourselves.
Great, thanks. Here's another one. Is predictive movement only applicable to Sweden?
No,
No.
we have had both questions from Norway, and they were interested, and also from Climate KIP, an EU organization. But what I'm doing right now is I'm working together with Finland, and we are also writing another application to see how predictive movement can be used with their initiatives and what we can learn from each other. That's the fun thing, or the fun thing. That's the great thing about predictive movement. We don't have to have one platform. As long as we have open source platform with open APIs that can connect, we can have different solutions in different countries, and that's important. And that's what we're also going to try and test in hopefully coming project.
Yeah, and as we said, we're not dependent on any APIs or data sources that aren't open. So whatever open data source is available in, for example, Finland and Norway, we can just switch to that data source instead, as long as it is open. So if you're listening to this and are interested to expand this somewhere else, that's exactly what we aim and hope for. To build this in multiple countries at the same time, or in multiple municipalities with multiple different types of innovation all together into one source code or one API or standards for solving these problems.
Thank you. Have you looked into collaborating with public transport?
Yes, we are doing that right now. In a project together with Länstrafiken. I work in Swedish and I don't have the words in English for this, I'm sorry, but the public transportation in Norrbotten, and it's demand transports that we're looking into, but also in this hopefully coming project, then this Steg 3, the third level, we want to help Länstrafiken to for the entire public transport. So the other with the demand transport, we are working for it's just started and we've got 4 years, and it's quite a big project.
I believe this question is directed towards the digital twin. What about weather disturbance?
What you have to understand that all of these things that we're working with are complex systems, which means that we have to find the solution very iteratively and try to find the easiest way to start. So what we are doing and how we are building the whole thing we are building is based on kind of how can we test this? How can we make sure that we find something that will an experiment we can test on that has a limited amount of a complexity, and so we can solve it. And the need for us to make the problem even more complex is not what we try to do, but rather the opposite way around. So of course there are going to be a lot of new things that we can add to the digital twin in order for it to be more accurately describing the actual situation. and traffic is one of them. Weather situations and other types of disturbances can of course be added on top of this. And I think the question also relates to the drone deliveries and if the drones are susceptible for weather changes, and that's definitely the case. So but what we need to do and to understand is if we're going to solve these complex problems on sustainability, we have to start somewhere, and we have to iterate together with and then solve each problem at one time apart. So there's a lot of interesting new problems that we see and effects that we can see, but those problems are not often very easy to visualize in the beginning. But by starting doing it and taking small steps, we have found a way to solve these problems together.
So what's the biggest obstacle at the moment, the most critical one, if you were to pick just one?
I think the biggest one is fear. I think that most people, if you ask anyone in Sweden right now, and everyone will accept that this is obviously a good idea to do. Like, why should we run on with empty cars, kilometers after kilometers on the roads? That's a problem that would be easy to fix, but the main reason why this is not happening today is that everyone has their business going about with their current existing operation and are having fear about change. They are fearing that this will decrease their revenue. They're going to change and disrupt their business model, and that data will be shared elsewhere. So there's a lot of fear that we need to kind of overbridge, and we have to do that, and by introducing and limiting the risk in each experiment is one way of tackling that. But fear is probably the most important factor that we aren't running faster towards the goal here.
And that's why we also digging deeper into the concept of digital trust. Now, both in the project running and incoming projects. I think our time is out. Wasn't this is supposed to run until 12:45?
It's 47.
Yeah.
We're having such a good time. That's why.
Yeah.
So thank you so much, everyone, for listening in, and we hope to hear from you and be part of this journey and be part of the predictive movement.
Thank you very much for listening. Okay, bye-bye.